So this is the tip of this month of October is going to be how to use recursion to process. You could use recursion for different things in functional programming, but most of the time you will end up using that to process lists. So lists are, they have a specific shape in functional programming languages. They are immutable. So we will see a bit of how lists are and how would you use recursion to process them. So a functional list actually has two main components. The first one is the head and the rest is the tail. So in this case, one is the head of the list. And we said that they are immutable. So what that means is that if you are trying to change a list, you are actually creating a new one. And that might sound like not very performant from that point of view, but because of the way that you tend to process lists in functional programming, what you do is every time you need to add a new element, we try to add it at the beginning of the list. And what happens is that each element in the list is going to have a pointer to the next element. So then if you add an element to that list at the beginning, that new element is going to be the head of this new list. But the old list is still there, and you could use it. And all the other pieces of code that were pointing to list 1, they have 1 as head, and that list is still valid. But the new code that needs list 2 is going to reuse the same items from the previous list, but it's going to have this new head.
So it's still kind of implicitly immutable, because if I change list 1 here, my list 2 going to be here.
Yeah, but you cannot change 1. So the cells are immutable. So the entire list is immutable, and you could be sure that whoever was using the first list is never going to change. You could add items, but still the previous list is going to stay as it was.
But you can make that list immutable, right?
If this is immutable, you could make it mutable. Yes, you could do that. So if you add the keyword mutable, you could, but what you are doing there is making, so you could change and add items to that list. If you really, what you are looking for is to change the items inside the list, that might be a better case for an array. Because arrays are those structures that you use also in functional programming, but when you know that the items inside are going to change. So how would you process a list? Let's say you want to filter only the even numbers in one list. Using the imperative mindset, what you will do is to, let's say you have a list there that has numbers from 1 to 4, and that's generating a list in F# for you with those 4 numbers, and you want to actually do what Hadi just said. You want to change that list while you are processing that. So the way that you do it in the imperative way is to use a for loop, and for each number you will ask if that is even. If that's the case, you are actually appending, and this is the operator that you use in list to append something at the beginning of the list. And we said before that in most of the cases when you work with lists in functional programming, you need to add things at the beginning of the list, and this is what we are doing here. But because I am changing the existing list, what happens here is that I need to say or declare here that the list is going to be mutable, because we are changing the list. But this is not the way that we should work in functional programming, because the whole idea of using immutable structures is that you could parallelize processes, and you don't need to worry about different parts of your system touching the same information. So the way that you should process lists is by using recursion. And this is a function that does exactly the same as the previous piece of code, but using recursion. So the first thing that you see there is that the function that is called even, that receives only one parameter, that is the list in this case, is going to be recursive. And we need to use the rec keyword there to be specific about that. Then what we have there, here, for the ones that this is the first time they see this shape of code. This is pattern matching, and what we are doing here is matching the list. So this ls is the first argument of that function, and we are matching that list with 3 different cases. The first case is what we call an empty list. So when we get an empty list, what we will do is this function will return another empty list. If we get something that is a head and a tail, and this follows the same pattern that we saw before, what Fchar is going to do is to put in the head variable what was the first item of that list, and it will keep in the tail what is the next list of items that that list has. But this line not only checks that you should have a head and a tail, but also checks that the head should be even. So if these things are true, so if you have a head and a tail, and the head is even, then what we do is to return a head concatenated to a call to this same function that is called even, but this time passing the tail. So we decompose the list in head and tail. We know that this is even, so we will use the head, and we will call the same function again, but this time with a shorter version of the list that is going to be the tail. And the last one is actually saying, yes, it's also going to check that you have a head and a tail, but we don't actually care about the head in this case, so we use the underscore, so then the compiler won't keep the value there. And the only thing that we care here is the tail. So the only case that is last here is when the head is actually not even. And in that case, what we do is to call the same function again, but this time using tail, but we skip this part, so we don't keep the head. So you see this working. Let me show.
Just a question.
Yeah.
On the syntax, it's kind of a right to left evaluation order, right? Because otherwise you need brackets on even tail.
Yeah. So in this case, you could put the brackets, and it's going to do the same. But yeah, you're right. Yeah.
Because somehow the call is binding more than the
Yeah.
end of record.
Yeah. And we could try it here. So here we have a list that we generate, and you see here the list generated. And then here we have the same function, and you see here that we are using the brackets. And here, by sending that to the interactive, we have the signature of that function that I just sent here, that is saying that it's expecting to receive a list of integers, and it's going to return a list of integers. So when I call this even function with the numbers, what I get back is just the even numbers. So let's see what happened there, how this works in more detail. So in the first case, so we had the list that had those 4 numbers, and what we do is to call this function the first time, and we ask, is the list empty? No, it's not empty. Okay, is the head empty? Is the head even? No, because the head is number 1. So then what we do is to go to the last step here, and we call the same function again without carrying the head. Now the head is number 2, and we call this again. Is the list empty? No. Is the head even? Yes. So because it's even, we keep the number 2, and we call this again with the tail, that in this case is going to be 3 and 4. So we repeat this again. 3 is not even. So we call this again with the tail, and we end up with this scenario in which we had the head and an empty tail. And in this case, the list is still not empty. The head is even, so we keep the number 4. We call this again, and the last step is that the list is actually empty. So we have number 2 and 4, and then the empty list. So that's why we got those numbers there. But there is a problem with using recursion. And that problem is the stack. Because what is happening here is that we are calling the same function for each element, and that grows your stack. And what is going to happen is that for just a few elements it's going to work, but if you have like a list this big and you try to do the same here, what you are going to get is a stack overflow that you got here. And this is actually going to kill your F# interactive that is going to come back soon. Yes. So, how do you fix that problem in functional programming? Well, there is a pattern that is called tail recursion. And this is exactly the function that we saw before. And what we are going to do is to convert this function to be tail recursive. And the way that we do that is by adding one extra parameter to the call, that is the accumulator. So instead of calling the function by passing the head and then calling the function again, what we do is to keep accumulating values as part of the parameter. And that is still, this is the functional mindset, that you don't share state, you just pass the state in between calls. So the accumulator here is going to have the current state of the list. So what we do here is instead of, when the list is empty, that will be the last step, what we do there is to return the accumulator, that is what at that point was the end result. And then for all the other cases, what we do is instead of having the head before calling the function, we call the function with the tail and we add the head to the accumulator. So now the accumulator is going to grow in every call. And we do the same in the case that the head is not even. We call this, but the accumulator is going to be the same, so we don't grow the accumulator, we reuse the same accumulator. So let's see how that looks here. So this is the one that you saw before. And if I send this to the F# interactive, now I have the same signature, but this time it's getting a second parameter that is accumulator, that is also a list. But the end result is still a list of integers. So I will get this again. So we have also, again, that huge list. And now what I need to pass here is an extra parameter that is the first state of the accumulator. So if I call this time, you see that this didn't throw a stack overflow exception. What did happen though is that we got the list that has only even numbers, but it's on the other way. Because what we are doing here is basically we are adding always the next item before to the accumulator. So you get things in the wrong order. So to fix that in a recursive, in a tail recursive function, what you do is to, at the end, in the case that you are working with list, you could call list reverse. So what you do is at the end you return the accumulator but in the other order. So if I change this and I call it again, you see that now I get it. I got those, but without the stack overflow and in the right order. So now that you learn how to use recursion, the truth is that you won't use it very often. Because especially for lists, you have a lot of functions that are part of the list module that will make your life easier most of the time. So if you want to do what we just did here, you will actually use the filter function that you have there that will give you a new list with that function applied. If you want to reduce a function, let's say you are adding numbers, you could use fold or reduce, you have depending on the overload that you need. And basically you have all the same functions that we have in C# for link and more here in F#. This is a reduced list, but if you go to that link, you will have the entire list of functions there. So we already saw the demo. I think I might have, not here. Yeah, this is another way that you could do it by using, so what I'm doing here is to, so I have numbers and I am pipelining that to the module list, the function filter, and I am just filtering the ones that are even. So if I execute this, I get exactly the same result, but this time I haven't had to write any recursion. Having said that though, there are cases in which you need to write your own recursion functions. So yeah, that's pretty much all. So the idea is to understand how recursion works and how to do it in a tail recursive way. Thank you.